my name is Kirsty. I'll be starting off where I pass over to Karen. So immediately after a flood event, SEPA will go out and gather as much information as we can about the flood event which has just taken place. We use this information in a lot of different ways, and it underpins a lot of the work which we do to meet our statutory duties under the Flood Risk Management Act. I won't go through all these in detail, but generally the type of work that we tend to use this information for is model calibrations, so flood warning models, flood hazard map models. We use it for high flow ratings and improvements to those ratings to get better flow estimates for modelling. We use it to review planning applications and for flood warning improvements as well. So this information is really key for us to improve our understanding of flood risk across Scotland. So what sort of information are we talking about collecting? We're talking about a variety of different things. We have topographic survey data, which we can collect internally or from external contractors. We have hydrometric data, which we can use to infer return periods. Photos and videos. We have media reports, and obviously with things like social media, that's becoming a much bigger source of information for us. We also have incident reports from external sources, and various different reports, things like flood risk assessments, which may include flood history. In terms of how we tend to use that data, we mostly use it on a spatial basis and on a daily basis. So we have point data which we use to look at impacts at specific locations, maybe look at flood levels. We have lines which we'd use to look at trash lines, and then also polygons to look at flood extent so we can understand the areas that were impacted on a bigger scale. At the minute, to help support all of that work and help us improve our products and services, we're undertaking a wider project which looks at improving our data capture, management and use. In terms of data capture, we're looking to improve our technologies and our procedures to try and make things a bit more efficient and speed up the process. In terms of data management, we're looking to streamline things, create one database that we can find our information within more easily, and then we're looking at different methods for sharing that data afterwards. In terms of our data capture, we undertook a pilot earlier this year, the end of last year into the start of this year, to look at a new method which Karen will go into soon, but I'll just quickly give you an overview of why we need to change the way that we're capturing information at the minute. So, the problem, so to speak. At the minute, as I say, we do collect a lot of information, but the way we do it is fairly inconsistent. We don't currently have a consistent tool that everyone's using. We don't have the same level of detail captured by every team across SEPA. There's a lot of different teams capturing different information for different purposes. So if you go out to capture something for your team, chances are that you're going to collect the information that you need, and therefore that information may not fit the bill for someone else's requirements. The way that we collect that information isn't always done in a spatial way, so there's a reduced spatial relationship. If we go out and take 100 photos on a camera, at some point someone has to come back into the office and put all those on a map, because as I say, that's the way that we tend to use that information. We don't always, we're not always clear on whether there's duplication of information. We don't have all the information that we currently hold to our fingertips when we're out in the field, so it's difficult to know whether the area that you're visiting has already been targeted for data collection. And I guess, again, linked to the reduced spatial relationship, there's a bit of a time lag between the data that we capture and then making that information more widely available. I'm sure a lot of people in here can understand that after any emergency incident, there's a lot of work going on. I'm sure you've all got lots of things to do. So for us, the priority is capturing that data. So it might sit there for a long time before we can get it all analysed and get it into a database and make sure that it's in a format we can share more widely. So there's a big time lag between our data capture and then making it usable. And for that reason, really, we end up with a potentially piecemeal data set. It can be difficult for us to find all the information we're looking for quickly. It can be difficult to get everything in one place. For that reason, we undertook the trial that I mentioned earlier, so I will pass on to Karen now, who can go into it in more detail.
Hi. So as Kirsty said, we recognised that we needed a mobile data capture solution. And as SEPA loves its acronyms, we thought that was a wee bit cumbersome to say all the time, so we've summarised it down to FEDCAP, a flood event data capture tool. So for the sake of the trial, we decided to use ArcGIS Online and the Esri Collector app. And that's basically, as I'm sure those that were in the track earlier will have seen, you download the Collector app onto a device, you collect your data, and using the internet, that gets synced to the cloud, where ArcGIS Online hosts the platform and all the architecture that's associated with it. And then to get it into the SEPA environment, we download it onto our SEPA servers. So this fitted the bill for us because it meant that we could capture point information with photos and videos attached. And one thing that we haven't been able to capture as easily as we did over the winter, is we captured trash lines as well and attributed information to those areas as well. So for the sake of the trial, we had 3 iPads available for the use of this, which was sufficient for what we required. And we carried on from there. So why did we choose ArcGIS Online? Just to go into a bit of detail. First of all, it was technically free for us, as we already held an enterprise license. So this was part of it, and we weren't utilising it to its full capacity. So we thought we'd just see whether that type of technology would be useful. It's flexible, so it works on multiple platforms and devices, so it didn't matter whether in a long time we decided to go for Android, Apple or Windows, because it works on all of those. But most key is its online and offline functionality, which if some of you in the audience may be aware, once you go over a certain part in Scotland, it's like being over the wall in the north in some place of Game of Thrones. There is barely any signal, and you don't get Wi-Fi signal that often either. So offline has been key to our northern districts. But apart from that, as long as you have internet, you can access this anywhere. And it's secure. So in terms of the type of data that we're collecting, we need that security, and that's managed by the logins that ArcGIS Online sets up quite easily. But on a personal note, the reason that I thought that we should go down this route is that it was simple. I'm not an ArcGIS developer in any sense or form, but I was able to set this up in an afternoon, and people were able to go out the next day to capture data, which in this case was key, as we launched incredibly swiftly on the morning of Storm Desmond. So it was required in this take of things. So I'm going to quickly run through the methodology. I will go back to it, and I'm here all day, so if you want to ask in a bit more detail, because I'm aware that it's not long enough to go through this in detail. So we started off with 2 feature classes, a point feature class for collecting information and photographs, and a line feature class to collect our trash lines. I created some domains so that we had drop-downs in the field to make it easier to capture the information. And then I brought these into ArcMap. And it was here that I set up the symbology so that it was easily visible in the field, and set up some categories as well. And then it was as simple as sharing to a service. So you work through the wizard, it's just click a few buttons, it's so simple, and you host this to the SEPA portal. As long as you've got feature access turned on, that thing's key if you want to do this type of functionality, as that's where you get all your editability. So once you're in ArcGIS Online, you set up your editing permissions, so you can set it so that people have read-only, so they can just view the data, but in this case we wanted to have full editability. And then you bring it into a map and add a base map. So for the sake of our trial of a winter, we use the default Esri topographic, which is what you can see on screen, and we also had the option of using the aerial imagery, which in some places was incredibly useful. But in the future, we might look to use SEPA-created base maps, which our colleagues in the audience are looking at. And that might have more information that's directly catered to us. For example, our alert areas, our watercourse names, and things such as that. Then what I did is I configured the attributes, so some of the fields were relevant more for post-processing than out in the field. And then it was a simple matter of giving the iPad to our field officers. So as you can see, there are multiple maps on there, and that was because we quickly realised that when you are offline, in the north generally, you download your study area previously, and you have a set area that you set up. But if you're going to multiple sites in one day, it's better to have multiple survey areas. So that's why I've got duplications there, so you can switch between the survey areas. And in addition to that, we found that although the officers had set areas where they knew that there was flooding, en route to those areas, they might have observed extra flooding that we weren't aware of at the time. So by having a regional map with a coarser resolution, they're able to capture that information when they didn't have the Wi-Fi signal or the 4G signal. So as you can see there, you download your map. So once you're in the FedCap tool, as it is, all it is you collect a new feature by tapping on it. You choose, using the symbology, what you required. And it just so happens we're in Perth on the screen. And then what you can do as well is it zooms to where you are, using the georeferencing on your device. And then you populate your information in your attributes. And it's similar for the trash lines as well. So you can start streaming and actually walk along the trash line. So this was incredibly key because you just start and walk and you can go for as long as you wish. But if it's too dangerous to walk along the edge of your flood extent, as we like to preach our health and safety of SEPA while we're there, you can also tap on the screen and do it that way as well manually. Once you're happy with the information that you've got, it syncs up to the cloud if you're working online. But similarly, if you're working offline, it saves it to the device, and then you get this little icon here that tells you how many updates and features you've carried out and how many that you need to sync up. So as I am aware, that was an incredibly quick whistle-stop tour of the methodology, so I'm happy to discuss that in more detail at a later date. But to give you a wee bit more context, we were hoping for a few kind of low-level flood events this winter to test this trial. And it wasn't this winter. It was obviously extremely wet and terrible for the people that got affected. But for us undertaking this trial, and for all of us data nerds that are here, it was incredibly useful, but obviously still terrible for those that were affected. So as you're aware, we launched incredibly swiftly just before Storm Desmond, as we knew that this was going to be a big one. But we weren't aware that we were going to get several other big ones this winter as well. So just to give you a context, the December rainfall was 215% of the average long-term rainfall. So that's meant that 50 out of our 400 river gauges reached their record levels, and that's a significant amount. For example, the River Dee at Park up in Aberdeenshire was 1.34 metres higher than it ever previously recorded before. So that gives you some kind of scale of what we're looking at. And it wasn't just focused to one area, which is quite often what we deal with, significant flooding in one area. It was everywhere. As you can see from this map was generated using the outputs from Report-A-Flood, which is our public-facing webpage where you can report any observed flooding. It was across the whole country, and thousands of properties were inundated. The top left are scenes from Ballater, where caravans were washed down the river. Multiple main transport networks were cut off and inundated. Aberdeenshire in the top right obviously had extensive flooding, and that's probably the one that's been publicised most. Christmas was cancelled in some towns of Perth because there was flooding over the Christmas period. And down in Hawick, roads were washed away, falling into the river, and for those rugby fans, they couldn't use the rugby park for a while either, which just goes to show the extent of what we're looking at. But in terms of our trial, as I said before, it was incredibly useful. It meant that we could fully test whether this technology would be useful for our organisation. We got greatly improved data quality. We got immediately geo-referenced photographs, which we do have capability to do, but we have a limited number of cameras that are of that technology available. We could also technically geo-reference videos, as people were taking a reference of where the point was started and then taking a video of what they could see, which in terms for taking gaugings is quite useful because you can see how fast the river's going at that time. And it meant that we could link that information to that specific point related to the cameras without having to come back and post-process at that. It was all in one place, which, as Kirsty said earlier, is incredibly time-consuming and, well, it's a bit frustrating sometimes when you've got all this information and you just want to get to the bottom of it at the beginning. So this way, it's all here and you just have one point of reference to go to. And as you can see, we captured a huge amount of data over the winter. Over 300 points, over 600 photos, over 600 trash lines. And we wouldn't have been able to get that before. We saved a lot of time because it only takes seconds to log in and load up and a few minutes to capture. Now, it might take a few minutes just to capture a photograph, but let's face it, we're getting a lot more added benefit by having this information immediately available to it. And when you think about the time it takes to survey using standard level survey equipment, it reduces it by half because you're not having to stop and take those levels. You just start tracking and go, and that gets you your course assessment of where the flood extent got to. And it was also easy to share. At times we had members of staff in the central belt which were lesser affected that were assisting people in the north by looking at this data in almost real time, so they were able to assist and analyse as we went on and be able to prioritise where these guys were going to next. So it was incredibly useful in that sense. And when we looked at the accuracy, some of our colleagues went out with detailed survey equipment and FedCap on an iPad. So as you can see from the top right image here, the line feature class, that was taken with the iPad, starting to stream it. And the point feature class underneath it was using full detailed survey kit. And when we post-processed that after reprojection, there was 10 centimetres difference, less than 10 centimetres. Which, if you think about it, could be the difference between having your iPad in one hand or the other hand, or just walking side by side with our colleagues. So we're incredibly happy with that. And for the sake of the trial, we didn't include any elevation levels, but as you're aware, everybody comes in different shapes and sizes. So in order to get detailed elevation using this type of technology, we would need to incorporate the use of a staff, because I'm going to hold the iPad here, whereas my colleague who's 6'5" might hold it up here. That's a big difference when you're looking at flood depths. So we will always just use this for course assessments and then go to the detailed survey kit for those elevation levels as well. So I think you can agree, the winter trial was quite successful. We got a strong correlation between the surveyed data and the data captured via the solution. There's a huge reduction in time spent processing the data and a great increase in the quality of data, which means that we've got more certain that it is accurate data. We've backed it up, we've taken it duplicate times, so we know that it is validated. And it was consistent. Because people were using a pre-populated form, they knew exactly what was required to be captured, so they're all capturing the same method. And the feedback from our staff was generally positive. They're excited to be using a new tool. And when we discussed this with local authorities, they were incredibly keen to be using the same sorts of technology for the work that they need to do of a similar nature. So our future development, we are aware there were some things that we'd like to improve. So we are going to run a similar trial this winter, but tweaking it slightly. And we're going to look into different options of software, what else we can utilise, and different devices as well to see what works best for the type of technology that we would require in SEPA. We're going to simplify the form, as we probably had too many functions of the fields for what we required. You can't capture everything, and some impacts aren't immediately visible to people in the eye as well. We're going to add slightly more information to give our field officers more information, such as I said before, watercourse names or historic flooding extents, which means again that they can prioritise and analyse as they go without having to feed back to the office and get all that data in one place. Similarly, we're going to improve processes for increased consistency. So by just training our staff a wee bit more, advising them on the types of photographs that are useful, because we had a few photographs that were pictures of trash lines on grass, which is great to see, but we needed a wee bit more context just to lift it up a little bit. So those little tweaks. And things like which side of the trash lines to work on. And finally, we want to improve the post-processing script. There was still some manual post-processing that we were required to do. So what we're hoping to do is get a fully automated script, so it's just a click of a button and all that data is instantaneously ready. So to summarise, we had great business benefit from SEPA, greatly improved data quality and quantity. And if you just look at the timeline at the top, a simple matter of getting more trash lines means that we can create more flood extents, which goes into our modelling. And if we improve our modelling, we can improve our flood warning services. And if we improve our flood warning services, we can potentially get those warnings out earlier, which means that people have more time to take action and prepare. So that might be the difference between getting their sofa upstairs, getting their telly upstairs. So it will save businesses and public money by getting that improvement in the field. By having more information in the field, our officers are utilising their resources, they can make better decisions, and because it's instantaneous almost, we can make those decisions more usable. We can actually act on them at the time rather than having to analyse it post-flood and having to come back to it at a later date. And that's the same with the security as well. Because it's all secure, we can share this data without having to put it on a hard drive, put it in the post and post it off. All we do is we give people a login, and because they're looking at the same symbology, they know exactly what you're talking about. It's not what's this blob, it's look at this pink square here, that's where we've got this surface water flooding. So it's easily interpretable. But personally, as I've said before, it was simple to set up. As a non-developer, this is key. It didn't take time, you didn't have to go to GIS and IS, who are incredibly busy and they're dealing with lots of other SEPA problems. So we were able to do this ourselves, set it up and modify it exactly for the needs that we needed. So it meant that we got focused data and it was incredibly quick to set up. And there's lots of scope to do it in other aspects of the organisation as well. So I think you agree, it was incredibly successful, and as you can see from some of these testimonials from our staff, it was very well received. So thank you for listening, and if there's any questions at the time, we'll have to take them.